Hello, this is Miss Moore, and we're here to continue our discussion on gas laws. Today we'll be talking about Boyle's Law. Essential question, what is the relationship between the pressure and volume of a gas? All right, Boyle's Law. When the volume of a gas is decreased, the pressure of a gas will increase. So why would that be? Well, if you think about it, if you take the same number of particles and you smush them into a smaller space, meaning decreasing the volume, the particles will be packed closer together, resulting in more collisions, leading to an increase of pressure. And the opposite is also true. When the pressure is decreased, the volume will increase. All right, so Boyle's Law. The pressure change of a gas caused by a change in volume at constant temperature, meaning no change in temperature, is expressed as Boyle's Law. The pressure of a gas is indirectly proportional, indirectly this time, to the volume scale at constant temperature. So what does indirectly proportional mean? It means that the pressure and volume change in opposite directions, meaning if you increase the pressure, you're decreasing the volume. If you increase the volume, you're decreasing the pressure. So unlike directly proportional, where the variables move in the same direction, indirectly proportional means that the variables move in opposite directions. Okay. Because the temperature is held constant, it does not change. So the prediction about gas behavior using Boyle's Law, we're only going to deal with the pressure and volume. So this time, we get to ignore the pressure, the temperature. So we'll be using P1 times V1 equals P2 times V2. Okay, let's try a Boyle's Law practice problem. Now I realize that we have not done a Boyle's Law problem together, but being that it's very similar to the problems we've already done, why don't you hit pause and try to do this by yourself, then hit play and see how you did. All right, so our formula that we're going to use is T1 V1 over T1 equals P2 V2 over T2. Okay, and let's make a list of our variables. And let's read this through the story carefully and see if we can figure out what our 1s and 2s are. So it says an elastic container is inflated to a volume of 18 liters at a pressure of 1.26 atm. Being that we have 18 liters at a particular temperature, those two should go together. Let's see if those are the 1s or the 2s though. So then it says the container then expands to a new volume. So meaning that the 18 liters and the 1.26 atm are the 1s. So we're going to expand to a new volume, and that with a pressure of 105 atm, and what is our new volume? All right, so when we plug those in, we'll have volume will be 18 liters, and our pressure will be 1.26 atm for the 1s. For our 2s, we have 105 atm for a pressure, and X for our volume. We don't need to worry about the T's, because it's held constant. So now all we have to do is plug this in. So we're going to have P1 times V1, or 1.26 atm times 18 liters equals P2, which is 105 atm times V2, which is our X. All right, and when we go to multiply on the left, I came up with 22.68 atm liters equals 105 atm X. All right, now we need to solve for X, which means get the X by itself, so we will divide both sides by 105 atm. And this allows us to cross out our ATMs, and when I calculated that, I came up with 0.216 liters. Now, if you guys remember, we should go back and do our check to make sure. With Boyle's Law, pressure and temperature or pressure and volume are inversely related, which means if one increases, the other decreases, and vice versa. So let's see how we did here. So our pressure went from 1.26 to 105 atm, which means pressure increased. So volume then should decrease. So we went from 18 to 0.216, so that should be our answer. All right, that's it for today. Have a good one.